All right, cat 21 slot 1 question 7. Let's continue. um, Onion is sold for 5 consecutive months at the rate of 10 rupees, 20 rupees, 25, 25 and 50 rupees per kg respectively. A family spends a fixed amount of money on onion for each of the first 3 months and then spends half that amount on onion for each of the next 2 months. The average expense for onion in rupees per kg for the family over these 5 months is closest to what? Now, what is this amount of money is not told to us. It doesn't matter. It cannot be found and it doesn't matter. What matters is that, okay, it is some 2x for the first month, 2x for the second month, 2x for the third month, x for the fourth, and x for the fifth month, because for the last 2 months it's half that amount, right? So you can take it as a variable x, but from a competitive exam point of view, if you want to solve this efficiently, you don't want to take x. You want to take a number that gives us, uh, you know, fast mental calculations subsequently. That's what you want to try to do. The concept is average. So basically, the average expense would be total number of rupees spent over the 5 months versus the total, I mean, divided by the total number of kgs of onions you got over the 5 months. That is, the concept is simple. It is a pretty simple question to solve if all you care about is getting the answer. But how fast can you get it is basically the question. You can ignore this. I'm just basically reaching for a for comment there. It's not much there. It's just average, but the efficiency is in the assumption. So I would just say, if I want to assume an amount of money, it doesn't, you don't need a variable x. You can take a number. What number are you taking? You want to take a number which with which you can divide 10 as well as 20 as well as 25. So basically you're looking for a common multiple of 10, 20, 25. So I'd start off by thinking, let that number be 100. 100 by 10 is an integer, 100 by 20 is an integer, 100 by 25 is an integer, all good. But then, does it work for the second part of it as well? What is half a 100? 50. Is this 50 a common multiple of the 25 and the 50 as well? Yes. So good. Let's continue with this assumption and let's do the very easy divisions leading to integer quotients and then follow through and solve and get the answer. That is what you would want to do to get to the answer efficiently. Now, let's imagine that instead of 25, this was 40. What would you do then? So I would start out with, okay, 10, 20, 25. What is the LCM? That is 100. What is half of that? That is 50. Does 50, is 50 a multiple of 40 and 50? No, it's not. So I'll have to replace this 50 with a 200, which means this would become a 400. And then I do the calculation from this point on. 400 is a common multiple of 10, 20, 25, and half of it is 200, which is a common multiple of 25 and 50. That is probably what I would do. 40 and 50, my bad. That is how you want to approach this kind of a question to solve it efficiently. So basically, you're spending 100 rupees, 100 rupees, 100 rupees, 50 rupees, 50 rupees, and the rate, the unit price is 10, 20, 25, 25 and 50, giving you 10 kgs, 5 kgs, 4 kgs, 2 kg, 50 by 25 is 2, and 50 by 50 is 1 kg. So you have spent 400 rupees and you got 22 kgs. That's what you want to do. This is 200 by 11, which is double of 100 by 11, 9.09. Double of that is 18.18. Or you can say 198 by 11 is 18. You know that. And the closest integer value is 18. And that's basically it. Smart value assumption, especially when you have invariance, you don't need a variable, you need a number. Just don't take 1 or 10 or 100. Think about it for a second. What is a value that I can use so that my subsequent calculations are easy and fast and convenient? That's the main takeaway from this question. That's question 7. Let us look at the next one. Question 8. It's a nice question. Lot to say about this. Lot of points here. We will cover all of this. So what do you have in 8? If r is a constant such that mod of x square minus 4x minus 13 is equal to r has exactly 3 distinct roots, then the value of r is what? The best way to solve this question is graphically. You want to draw x square minus 4x minus 13. Y is equal to x square minus 4x minus 13. and then you want to do the mod transformation and see what this graph looks like. And then the other side is y is equal to r, which is a horizontal line. R units above the x-axis. What's a good value of r that will satisfy the given condition? So when you want to plot a quadratic expression like this, first you will have to do completion of square. We know that quadratic can be solved in three ways. Three techniques are commonly taught. One is splitting the middle term, one is completion of square, and the last is a formula. Completion is the one that helps us draw somewhat accurate graphs of these functions, so we can solve graphically. So what do you want to do? X square minus 4x is obtained by squaring x minus 2 whole square, which would actually contain of plus 4 as well, right? So it's actually plus 4 minus 13, which I'm going to write as x square minus 4x plus 4 minus 17. I'm replacing this minus 13 with plus 4 minus 17, which gives us x minus 2 the whole square minus 17. So what you're first trying to do is you're trying to plot y is equal to mod of this. So how do you do that? We start out with the y is equal to x square curve. I think I should move this a little further up. Y is equal to x square curve is going to look like this. What about y is equal to x minus 2 the whole square? The minus 2 is going to cause a right shift, and then the minus 17 is going to cause a downshift. So this is what's going to look like. This thing is this expression inside the mod, without the mod. Y is equal to x minus 2 the whole square minus 17. This point right here is 2 comma minus 17. It used to be at the origin. You shifted it right by 2 units, down by 17 units. Now it's at 2 minus 17. This is x minus 2 whole square minus 17. What happens when you mod it? When you mod it, the path that's above the x-axis remains there, while the path that's below the x-axis gets flipped up. It's gonna look something like this, and this point is 217. Now at this point it should be kind of obvious to you what the answer is from the options. Okay, so that is my LHS. This equation has an LHS and an RHS. The LHS is mod of x minus 2 whole square minus 17. So I plotted y is equal to mod of x minus 2 whole square minus 17. It's the green curve. And then the RHS is R. So we'll plot another y is equal to R. Let's take another color. Y is equal to R is going to be a horizontal line R units above the origin. If the value of R increases, it will shift up. If the value of R decreases, it will shift down. And we want 3 distinct real roots, which means that these two curves, the green modded quadratic curve as well as the purple straight line for the y is equal to r, these should cut each other exactly thrice on the real xy plane. Right now what you're seeing is it's cutting at 4 places. 1, 2, 3, 4. If you keep going down, it's still 4, it becomes 2, and then it becomes 0. This doesn't work. If you go up beyond this point, there's only 2 cuts. The green and purple cut at only 2 points, right? So nothing above this works, nothing below this works, but at this exact point, which is y is equal to 17, the horizontal line 17 units above the x-axis, this is the point at which this equation mod of x square minus 4x minus 13 is equal to r has exactly 3 real roots. So the best way to solve this is graphically. What all did we use? We had to do completion of square on the original quadratic polynomial, which helps us split it into a square, which is a horizontal transform and a constant horizontal shift and a vertical shift. So you have plotted the quadratic without the mod, and then you have the mod transform concept in graphing as well, which gives us the LHS. And then you draw RHS, very straightforward, horizontal line. And then the idea that real roots correspond to real intersections in the real XY plane, which is the only thing that we draw. We don't have to worry about the imaginary plane or anything. It's beyond the scope of our syllabus. What we draw as the XY plane is the real XY plane. So we want 3 cuts, and that happens only at r is equal to 17. So 17 is your answer. Completion of square helps us quickly get to this expression. And then there is the graph shifting concept and the graph mod concept that helps us plot it properly. The algebra concepts are quadratic and modulus function. That is question 8. Let's move on to the next question. Question 9. Amal purchases some pens at 8 each. To sell these, he hires an employee at a fixed wage. He sells 100 of these pens at 12 rupees each. If the remaining pens are sold at 11 each, he would make a net profit of 300, while he makes a net loss of 300 if the remaining pens are sold at 9 rupees each. The wage of the employee in INR is. Let's do it the straightforward, unoptimized way first, and then let's see what levels of optimization we can bring. Now, what is the total number of pens that he has bought? We don't know. There is the first part, that's 100 pens, and the second part is simply called remaining pens. We don't know how many are there in the remaining. We'll have to take that as x. So the total number of pens is 100 plus x. The first 100 bought at 8, sold at 12. The second x, case 1 bought at 8 and sold at 11. Case 2 bought at 8 and sold at 9. In both of these cases, there is a fixed salary being paid to the employee, and in one there is a net profit of 300, second one net loss of 300. So the most straightforward unoptimized way of doing this is to say basically income minus expenses is the profit. What is the income? Income is you are selling the first 100 at 12 and the next x at 11 minus you bought 100 plus x at 8 and you paid a salary. Net income minus expenses should be profit, and this would be 300 rupees. Second case, you sold the first 100 at 12 again, the second x, the unknown x, at 9 rupees instead of 11, and again the procurement cost is 100 plus x into 8 and the other expense is the salary, and this time you have a loss of 300. Now the only logical thing you can do to this is to subtract these two equations, and when you do, this gets cancelled, this is different, so that's a 2x. This gets cancelled and this gets cancelled, and then 2x is equal to 600 gives you x is equal to 300, which means the second part was another 300 pens. He bought and sold a total of 400 pens. Once you get this x is equal to 100, notice that both of these equations have two variables. Linear, a pair of linear equations in two variables, x and sal, is basically what we have. So now that we've found x, you can substitute either in the second equation or the first equation. You should get the answer. So if you substitute it back into the first equation, what do you get? You get 1200 plus 300 into 11 is 3300 minus 400 into 8 is 3200 minus sal is equal to 300, and you can solve for salary, which is this is just 100. 1300 minus 300 is 1000. This is the rigorous solution that you would find in a textbook. Now, what optimizations can you bring to it? Level 1, I would want you to look at these two cases and think, what is the difference between these two cases? Ignore the similarities. Look only at the differences directly when you're framing. You don't need the full equation. if you know and if you can predict that the next step is I'm going to subtract these two equations, why bother with these similarities? Just look at the differences, right? So if you solved x at 11 versus x at 9, the difference between these two cases is the difference between plus 300 and minus 300. This would directly give you 2x is equal to 600 and x is equal to 300. And from there you can frame either of the cases and solve. That would be one level of optimization. Now I'll tell you what I did when I first saw this question. You might not like this, or you might, I don't know, but I'll tell you anyways. My thought process when I saw this question was immediately to think, if you were to sell at the second part, the unknown x pence, if you're selling the second part at 11 and you get plus 300 versus 9 you get minus 300, that means if you had sold the second part at 10 apiece, you would have broken even. This is where my mind goes. I don't know if it's good or bad, but that's how I operate. You don't have to do this again. If you understand it and you like it and you think it's efficient, you should maybe look into it. Otherwise, ignore it. So I was thinking, let's create this third case with the break even and frame there, and that might probably be more efficient. And then instead of looking at CP and SP separately, I directly looked at the profit for each pen. So there's one more step here. One is that if you had sold the second part at 10 apiece, you would break even. The other is you can look at this. Okay, 1 extra rupee for expense is 300 extra rupees. 1 extra rupee for expense is 300 extra rupees, which means that x is 300. With this you can get without writing these long equations. You can reason this out verbally is what I'm trying to say. 1 extra rupee for expense is 300 extra rupees. So I found out that x is 300. I've also taken the middle value and said that would be break even. These are three things I'm doing. Direct difference equation, middle value is break even, and x is 300, right? So the difference equation being, you don't write the full equation. You only write the part that's different. Ignore the similarities and find only the differences. And then the fourth part is I am gonna frame this in terms of profit instead of SP minus CP is equal to 0. Let's look at the profit for each pen. So I have first 100 pens where it's bought at 8 and sold at 12, so 4 rupees profit. And the next 300 pens bought at 8 and sold at 10 for 2 rupees profit, and this is just enough to offset the salary. This might seem convoluted, but if you can think like this, you're doing less calculations. That's all I'm saying. And this is just 1000. You do this, salary is 1000. We're just trying to minimize the burden of calculation. We don't want to find 4500. It is possible to get this answer without getting these larger intermediate values. Just get straight to the answer. Again, this last bit, if you're not comfortable with it, don't do it. It's okay. But these are possibilities. I don't think I've tagged much in this question, but yeah. I guess this difference thing is just like in the previous video where I said, equation 1 divided by equation 2 gives you a ratio equation. Just like that, there's a difference equation. And you can frame directly into the difference equation without writing equation 1 and 2 before that. Save yourself some time. That is question 9. Let's move on to question 10. Anil invests some money at a fixed rate of interest compounded annually. If the interest accrued during the second and third year are 806.25 and 866.72 respectively, then the interest accrued in INR during the fourth year is nearest to what? I would just take a calculator and do 866.72 into itself divided by 806.25. 0.25 and say that the answer is 931.72, and that would basically be it. That is all you need to do there, and I'll explain why. So let's take an example. It's the same example that I use all the time. If you had a principal of 10,000 rupees, let's say, and the rate of 10% per annum, what would the amount look like at the end of the first 4 years? You would have 1,000, which would generate 10%, and it would become 1,100. This would generate a 10%, which is 1,100. It will become 12100. This will generate 10% is 1210. It will become 13310, and this will generate 1331, and you get 14641. Now you'll notice that these numbers are in GP, with a common ratio is equal to 1 plus 10%. This same 10%. And these numbers are also in GP because each number is 10% of the number just before it. So if the first sequence is in GP, the second sequence should also be in GP, right? So the interest accrued in consecutive years, let's take 3 as an example. These will be in a GP. And what do we know what the geometric mean? B square is equal to AC, right? B square is equal to AC, which means if I wanted the third term, C, it is B square by A. That is what I did at the beginning. 866.72 into 866.72 divided by 806.25. This would straight up give you the answer. So the main concept here is that SI, the amounts in SI and the amounts in CI behave like an AP and a GP respectively. And when it comes to SI, the interest each year is equal, right? That's how you get an AP, right? Each time you're adding the same number. So the differences are going to be the same. The interest for each year are going to be the same for SI, but for CI, common interest, those amounts incurred, accrued each year would also be a GP. So if you know this concept and the analogy between SI, CI versus AP, GP, you can straight up just do this and get the answer. That is question 10. Answer is 931.72. Let's look at question 11. The strength of an indigo solution in percentage is equal to the amount of indigo in grams per 100 cc of water. Two 800 cc bottles are filled with indigo solutions of strengths 33 and 17 respectively. A part of the solution from the first bottle is thrown away and replaced by an equal volume of the solution from the second bottle. If the strength of the indigo solution in the first bottle is now changed to 21%, then the volume in cc of the solution left in the second bottle is how much? So it's a simple question. The crux of this question is simple, but there's a little bit of extra stuff at the beginning and the end, trying to throw you off. Not complicated, but you can't lose focus. It's possible that you will lose focus because of how easy the middle part is, and you might get it wrong in the last bit just on account of being careless. So you gotta be wary of that. That is all. Not a very tough question. Solutions, mixing solutions, very straightforward stuff. So basically you have a certain amount of the first solution, 33%, left in your first bottle, and you are mixing a certain amount of second solution, 17% solution, taken from the second bottle and poured into the first bottle, and the resultant mix is 21%. We know what happens here. We can put these on a number line, find the distances, simplify that ratio, and invert that ratio to find the volumes of liquids mixed. So that means out of a total 4 parts in the first bottle, which is now refilled, right? A part was emptied, thrown away, and then replaced with the weaker solution from the second bottle, and now it is refilled. So these 4 parts should be equal to 800 ml, 800 cc, same thing, right? So that means this 3 is 600 cc and this one is 200 cc. The solution left in the second bottle is what they're asking. So what's happened here is that from the initial 800, only 200 is left. You first threw away 600 cc and you are left with 200 and a 600 cc vacuum above it. There you poured the second weaker mixture from the second bottle, which has now lost its 600. What's left in the second bottle is now 200. So the thing is, the actual mix is 600 200, but they're talking about the remaining 200 in the second bottle. There was a 600 that was thrown from the first bottle. This is the actual mix. So a little bit of extra stuff there, trying to break your focus and, you know, accidentally make you write the wrong number. But a simple question, conceptually very simple. Left in the second bottle is this 200. That's what they want. The concept is using number line for weighted average. You don't have to use number line, you could use the formula. Doesn't matter. Nothing much, it's just weighted average. Alloy slash solution is being mixed. That's it. Yeah, I've written it here. It's not necessary. Number line is not necessary, it just makes you faster. That is question 11. Let's look at question 12. Amar, Akbar, Anthony are working on a project. Working together, Amar and Akbar can complete the project in 1 year. Akbar, Anthony in 16 months. Anthony, Amar in 2 years. If the person who is neither the fastest nor the slowest works alone, the time in months he will take to complete the project is what? Now, typically these kind of time and work questions are invariant. Question 12, you'll notice I've written invariance, because it's usually invariant of the actual quantity of work. Everything is done as a fraction and you find a final time. Smart value assumption is always a good idea in these kind of questions, and I'll show you why. So the individual times given are 12 months, 16 months and 24 months. Usually what I do is I take the work, we assume the work, right? I don't like taking 1, I take the LCM. So 12, 16, 24 as an LCM of 48. Let the work be 48 units, which means Amar and Akbar can do 48 units in 12 months. They do 4 units per month. Akbar and Anthony can do 16 months. So that's 48 units in 16 months, or 3 units per month. And then Amar and Anthony can do it in 48 units in 24 months. That's 2. So this smart value assumption gives you easier calculations afterwards. That is the point of it. The rest of it is very standard. Everybody would be doing the same thing. This is a very standard situation where we have 3 equations in 3 variables, and unit coefficient but 1 variable missing in each equation. Standard scenario that you encounter frequently, standard approach to solving it. Just add the 3 equations. You will let 2 times m plus k plus n is 9. Half the equation, m plus k plus n is 4.5. Now if you compare this with any of these, you can find the missing variables value. So if you subtract the first equation from the last equation, you would get n value. N is half. And after that you can repeat that process with the second or the third, or you can take this n that you found and throw it here and here. Either way, you will fully resolve this system of 3 equations. K is 2.5 and m is 1.5. Now you also don't need to resolve. This is the other thing you should notice. They're asking about the time taken by the guy who's neither the fastest nor the slowest. So if you want to fully optimize it, you will remember this part of the question and you will say from 4.5 I am going to subtract the middle of these 3 values, which will give me the middle of these 3 values. Wait, did I get that right? What happened there? Give me a sec. 4.54 is half, 4.53 is 1.5. I got it upside down, didn't I? M plus k is Something is wrong somewhere. Oh, I wrote the wrong letters. Ay, ay, ay. Did I? Yes, I realized my mistake. So basically, what happens there is the middle value corresponds to the middle value for the missing variable. That is the problem. This 3 is the middle value out of the 3 here. What's the missing variable in that equation? That is the missing middle value in these 3. You gotta be careful with that, I guess. So anyway, you can either way you could find all 3, or you could just straight up identify that m is the middle value and find only that, which should be more efficient, I guess. After which point, what do you do? The time taken by m would be the work divided by the speed. The work we had already assumed to be 48 units. Amar's speed we just found to be 1.5 units per month, and when you divide, you'll get 32 months. So everybody's going to be doing this in a similar approach, not much there, except that if you have never considered using LCM of the individual times given, that is worth exploring. Try it out. It gives you easy calculations. Answer: 32 months.